Assalamualaikum and hi everyone. My name is Salsabila Nur Aisyah binti Muhammad Badrul Hisham. My matrix number is 2025137483. I will cover the introduction of Snapdragon 8 Gen 2 and also the execution engine in the Cairo CPU architecture.
Hi, Assalamualaikum. My name is Naala Usman binti Fauzi and my student ID is 2025381479. And my part is memory subsystem, devices, and also summary.
Hello guys, my name is Nasiha Humaira binti Muhammad Nizam and my student ID is 2025137917 and I will cover the part of the overview of the architecture and the front end.
We start with brief introduction about the Snapdragon 8 Gen 2 model. Smartphones today aren't just for calls or messages. They are our cameras, game consoles, and even AI assistants. But what makes that possible? It all starts with the heart of the device, the system on chip, or we call that SoC. And one of the most powerful SoC out there is Snapdragon 8 Gen 2, developed by the Qualcomm company. In this presentation, we'll take you inside this chip, explore its architecture, but before that, I want you to know that this chip is not just a processor. It is an entire ecosystem in a single chip, integrating CPU, GPU, internet service providers, and wireless modules.
Now, I want to explain in detail about the overview of the architecture in Snapdragon 8. The first component is the Spectra ISP, or ISP also known as image signal processor. This part is responsible for handling everything related to the camera. It processes photos and videos from multiple camera sensors. The Spectra ISP support ultra-high quality features like 200MP photos, 8K HDR videos, and real-time face detection using AI. It helps produce sharp, bright, and beautiful image, even in the low light. So the second component is Adreno GPU, which is GPU is stand for Graphic Processing Unit. This part takes care of rendering visuals such as animation, videos, and 3D graphics. This is especially important for gaming, where it creates smooth and realistic graphics. In Snapdragon 8, the Adreno GPU even support hardware accelerated ray tracing, which means lighting and shadows look more realistic in games. So the third component is the hexagon processor, also known as AI engine. It handles artificial intelligence tasks such as voice recognition, object detection, and language translation. This processor includes different types of accelerator such as Scala, Vector, and Tensor, which make AI function faster and more power efficient. Next is Sensing Hub. Sensing Hub is a small low power unit that runs in the background. It handles wake-up word like Hello Google and other always-on features. The best part is it does all of this using very little battery, helping your phone stay responsive all day long. The next component is processor security. This part protects your phone from threats. It ensures your device starts safely, and it protects sensitive data like fingerprints, password, and payment information. It also enables things like facial recognition and secure access to apps. Overall, it keeps your phone safe and private. And next is Cairo CPU. Cairo CPU is like the brain of the system on chip. It manages all the main tasks such as opening app, running the system, and background processes. In Snapdragon 8, the CPU uses a mix of performance cores and efficiency cores. This design helps deliver fast performance when you need it and save power when you don't. Next component is the Snapdragon 5G modem RF system. This is the part that connects your phone to mobile network like 4G and 5G. It supports the latest 5G technologies like mmWave and sub-6 GHz, giving you super fast internet even in the crowded place. It also improve signal strength and save battery during data usage. Okay, the next component is the Fast Connect system, which is they manage your phone Wi-Fi and Bluetooth connection. In Snapdragon 8, it supports Wi-Fi 7, which gives faster wireless speed and lower latency, giving for streaming and online gaming. It also supports Bluetooth 5.3, which helps save battery while using the wireless earbud and other device. See, all these parts are connected through the shared memory. This means the CPU, GPU, AI engine, camera processor, and others can quickly share data with each other. Fast memory access is what makes your phone feel smooth and responsive, especially when multitasking or switching between apps. Okay, now I will explain the front end of the Snapdragon Cairo CPU. The first instruction is the CPU fetches instructions from the L1 instruction cache. This cache is a small, fast memory that stores recently used instruction. The CPU uses it to quickly get the next step it needs to run. This is like the checking your to-do list. The next is prediction. This part tries to guess what instruction comes next before it actually knows. After fetch, the CPU decodes the instruction. This means it translates complex instruction into smaller pieces called micro-operation, which are easier to handle. It uses a 4-way decoder so it can decode up to 4 instructions at once. Okay, next, the CPU uses the rename unit and register alias table. These tools help rename registers, which are like small memory boxes. If 2 instructions are used in the same register name, renaming avoids confusion and prevent error. Then finally, the CPU dispatches the instruction to the execution units, which are like workers during the actual job. The CPU can send up to 4 instructions at once to be processed. This is where the real work happens, like adding number, accessing memory, and perform logic.
Now, let's zoom in into one of the most critical parts of the Cairo CPU, which is the execution engine, the section where real computing works happen. This engine is powered by multiple intelligent subsystems such as branch order buffer, reorder buffer, schedulers, register, file and forwarding network, and ALU, IMUL, AGU, and branch. First, we have branch order buffer to store information about in-flight branches to ensure correct speculative execution and recovery from its prediction, meaning that it helps CPU to guess and prepare for future instructions, enabling faster performance through speculative execution. Let's move on to the schedulers. These schedulers manage the dispatch of micro-ops to the appropriate execution unit while ensuring efficient utilization. Okay, so it tells that the instructions are sent through schedulers which act like the traffic controllers. They decide which execution unit should handle which micro-operation, whether it's arithmetic, logic, or branching. Next, we have the reorder buffer. This is to complete micro-ops in program order, allowing out-of-order execution while maintaining the appearance of in-order, meaning that it allows instructions to run in any order for maximum speed, but still ensures they are completed in the correct sequences. After that, we have register file and forwarding network. Provides fast temporary data storage between execution units. This is to support smooth data flow between all these units. The register file and forwarding networks provide quick access to temporary data, avoiding delays. Last but not least, in the execution engine, we have ALU, IMUL, AGU, and branch. These general integer operation, integer multipliers, and a dedicated branch execution unit in execution engine. So these operations are carried out by specialized units, including the ALU for math and logic, the IMUL unit for fast multiplication, AGU for calculus address, and the branch unit for control flow decision.
Now I will explain the memory subsystem in Cairo CPU core of Snapdragon 8 Gen 2. Do you guys know what is memory subsystem? The memory subsystem is the part of the CPU that manages how data is stored, accessed, and moved between the processor and the memory. Its main job is to make data access fast and efficient, helping the CPU quickly read or write data needed for processing. So let's go through the component in. So, when the CPU needs data, it first goes through the load and store unit, which control all the memory-related operations. This unit has a load queue and the store queue. Each tracking read and write operation. It can transfer up to 16 bytes per cycle, which helps maintain the high performance. After that, the CPU checks the L1 data cache, which is the fastest and the closest memory. If the data is there, it's a cache hit, and the CPU gets the data quickly. But if it's not, it moves to the L2 cache, which is the bigger but slightly slower. The L2 cache is shared across multiple cores and can be either 256 KB or 512 KB. Well, if the data is still not found, it is traveled through the SoC interconnect to reach the main memory or RAM. This interconnect also links the CPU to other components like GPU and NP. And lastly, there is the TLB, which is the Translation Leukocyte Buffer, that helps the CPU translate the virtual addresses into physical addresses faster. This avoids the delays and keeps the memory system efficient. There are several premium mobile devices that are powered by Snapdragon 8 Gen 2 chipset, including the OnePlus 11 5G, Samsung Galaxy Z Fold 5, and Asus Zenfone 10 5G. These flagship smartphones benefit from the chipset's advanced performance capability, offering faster processing speed, improve energy efficiency, and enhance the AI features. As a result, users can enjoy smoother multitasking, better gaming experiences, and overall improved device responsive. This makes Snapdragon 8 Gen 2 a top choice for high-end mobile technology. In summary, this study explores the architecture of the Snapdragon 8 Gen 2 system on chip, focusing on its Cairo CPU core with key components like front-end, execution engine, and memory subsystem work together to deliver high performance, low power consumption, and efficient data handling. This architecture enables modern smartphones to support advanced tasks such as AI processing, high-end gaming, and seamless multitasking, proving the Snapdragon 8 Gen 2 role as a powerful and integrated mobile platform.
That brings us to the end of the video. We hope this exploration of the Snapdragon 8 Gen 2 has been both enlightening and informative for you. Thank you!